Hello, everybody. Hello. Uh, I'm Elijah. Um, I'm part of the hosting team here, and I will be presenting something with you also today. Um, we have had amazing speakers who have talked about DevSecOps unveiled, uh, but also Rachel, who was delve a little bit deeper into securing WordPress sites. So I just want to kind of keep the same way uh, and trying to show us well something about securing the development cycle. We are developers, right? And who would actually take this bus or the tuk-tuk or the motor and come here knowing that the motor wasn't secure? Nobody could ever try that risk. So I think it's just the same thing that applies to us as developers. Whenever we are building, it's like whenever we're building products, it's like we are trying the journey. We are starting on a journey, and you want the security to be part of that journey till the journey ends. So we just want to add a little bit of spices into that and try to see how, okay, like a friendly demonstration of how we can incorporate security as part of our development. And unfortunately, I'm not able to do like the coding, the fun thing with you. So it's just gonna be demo. If we had a good setup, that would be actually very amazing. But so it's just gonna be demo. Bear with me, because I can't hold the mic and keep touching my laptop at the same time. So I'm just gonna go through an already built up and go through the same process. Just yeah, gonna bear with that. Uh, so we're gonna go actually through what are we gonna build first of all. So we're gonna try to look into a Node.js service. I think we are all familiar with JavaScript, right? JavaScript is for everybody. So I know we probably are all familiar with JavaScript. So you're gonna go with Node.js. We're gonna try to build a Node.js service with Nest.js, of course. And then we're gonna try to establish a communication between two services. So the intent is to see how can we actually make sure we are protecting our communication. That chain is protected. In Chris's talk, he actually mentioned something about API key security. We are just gonna try to have a glimpse into that. How is that possible? How do we achieve that? But also, we are also trying to see how we can have a more broader security with our API endpoints. Uh, you're gonna see. You're gonna see. Let me not dive into it. So, enough with the talking. Let me just bring the codes and let's start just going through it. Uh, so it's all over here. I'm just gonna do this. Okay. Wow. This is gonna be fun because I'm not able. I don't know how I'm gonna stand, but let me do this here. Okay. Let me do this. Okay, this is better. So nice guy. Is that good? Or you also suffer from eyes like me? Can everybody see there? Or can I change the light more? This one says, okay, all right. Yeah. that better? Maybe more. About 30. Good. Okay, that's good, right? Is it okay? Up there? Okay, cool. Uh, yes, so as I just said, we gonna go through two services here. As you can see, right here we have a notification service and here we have an event service. So this event service, let's consider it as a service where you're gonna be registering for certain events, like DevSecOps Connect. So you had to register. So you're gonna expose an API endpoint that users are gonna utilize to register to events. But also it's gonna provide as well another API for to list reservations. So of course, and you're gonna have the notification service. So what we're gonna do is just we're gonna mimic, because it's not sending any notification, but the purpose is to send a notification. We're not sending a notification actually. Well, so let me go just through it real quick, just demo. First of all, this is the event service. So to people who are not used to Nest.js, bear with me, but it's still JavaScript, and JavaScript I hope you just understand the idea, right? So I just have some seeders here, some data seeders, and these are just some scripts. And what we are doing is just inserting some data to play with, because we are actually not going to be dealing with data insert and all of that. So I just insert some data to play with. And apart from the seeders, I have the controller here, and you can see that the controller is exposing this API endpoint, API/reservation, and it's just there to list the reservations. And we have another one to actually make a new reservation, and we have another one to list the events, and then some other one here actually. And then I also have the service class right here, and what the service class is doing is just connecting with the controller to just serving the controller and connecting to the database through the Prisma client. And then I have this middleware, we're going to check it later, and then the application is just running on that port here. So just basic things, no, not basic things. And then on the notification service, I also am exposing. Let me go to the controller. Oh, yeah, I also have a controller here, and this controller is exposing as well one endpoint to send email notifications. And actually, basically, that's only it. So let's just do a quick test. So I'm going to bring my API client right here. Sorry. I'm going to bring my API client. Let's try these endpoints and see what we are doing. I don't know how I can zoom, but I hope you can see. Yeah, wait. Control plus. Thank you. Good. So we have this API here, which is actually listing our events. So you can see, I can call it and let me hope I get the list of events. We didn't. Okay. It's not running. Okay, just a minute. Good. Mhm. Yep. And yeah, you can see we have the list for events right here. We have this second connect, and actually people who registered already. Of course, I had some data in the database, you understand. Um, yeah, so we can as well make new reservation right here. Just click it here and sending this to data, and you can see the user has reserved the seats. And we can as well list reservations. So just actually a demonstration of the API I just showed here. Um, yeah, and lastly, we can send as well an email. So you can see what's the concern actually here is that the notification services, they are, it's not actually, we're not talking about microservices here, but we're talking about two services that kindly somehow don't know each other. So you can take it as, who uses Twilio? Who has used Twilio before? Some of us. Or SendGrid. I'm pretty sure you're familiar with those services as well. So you may use Twilio to those who don't know Twilio to maybe send texts, sorry, SMS messages and other things. You can check their websites. You can use SendGrid, you can use, there are many third-party services that you can integrate into your application. And you see, it's another service. They don't know you, you don't know them. So how do you make sure, or how do they make sure that they trust you to use their services? So you see, there got to be some kind of identification to know that this is actually Elijah trying to connect to us. And we take the same thing with the notification service. So the event service and notification service somehow don't know each other. And they want to communicate. So the event service, I'm building the event service, but I want to connect with the notification service to be able to send notifications. So the two services don't know each other, but I'm coming then, I'm going to the notification service. I'm like, okay, boy, I want to use your service. The notification service will not let me use your services just like that. They will have to know who I am. So I'm going to register. And when I register, they're going to provide me with a key. And that key will be a private key that's going to identify whichever communication I will try to establish with the notification service. So whenever I'm going to hit the notification service endpoint, which in our case is the send email API endpoint, I'm going to pass a key. That key was issued by notification service. So I went to notification service, I created an account, and notification service said, okay, we are giving you this key. Whenever you want to use us, use this key, and we're going to know that's you. That's going to identify you as one of our subscribers, one of our people. So I'm going to have to pass that private key whenever I'm hitting the notification service. And that's actually the intent or the idea behind this model here of schema. So we are trying to mimic that same scenario where we have to protect the public API endpoint from an unknown source because we don't know who's the user going to be, but still want to identify who they are. How do we do that? Through now the concept of API key as one of the ways. Not the way, but one of the ways, right? We can achieve that. So how did we implement that through this application? Let's then go back into the code and see. So you can see that in one of my classes right here, in the notification service, I have, let me go to, I'm gonna close that. And the source, I have this, where is it? Client tab registration service. So what this actually is doing, nothing big, it's just assuming we have a whole registration process that happened for a client to register. So the client in this case is the event service. So we assume that event service logged in the notification service and they created an account. And after creating the account, notification service issued them an API key called my secret API key. Right. So we assume, of course, we didn't implement the registration here. So what is this key gonna be used for? So whenever event service wanna access notification service, event service will have to provide this key. And if they don't, then the request is gonna fail. It has to fail because notification service will tell, okay, who are you, boy? Why are you trying to refuse me? So it has to provide that key whenever it wants to connect to the notification service. And that's actually what we're doing here. And we have this method of this class. What it's doing is just returning that, nothing crazy. But you understand that that should be a real validation of the key that will be happening there. But here it's just for demo purposes, just to show the how we can implement it. But that should be probably a database call. You check this key, this user, are you the one logging in, all of that stuff, and you just put them there. So how are we then? We see here we are registering the application and giving the third-party user an API key. How the API, how does the client with the third-party user now giving us back the API key? So whenever notification event service switches the clients, when I connect to the notification service, they will have to pass that key, my secret as you saw there, in some ways. And in this case, we are actually passing it through a header. So we can go to app service and here we have this thing here, make reservation. So what's the idea here? So whenever a user is making a reservation and we have saved their reports, we want them to send their notification that, hey, your seat has been reserved, something like that, you understand? So when the user is just making the reservation here and all has gone well, we are calling the notification service right here. And we are saying, okay, go, man, just send the notification, send the email notification. So what is this method doing? So let's just navigate to it. If you go there, it's actually under notification service TS right here. You can see we are connecting to the other API, send email. But whenever we connect to it, what are we doing? We are actually passing one header here called X API key. And we are passing my secret API key right there. So if you make that header, notification service is gonna check, did you really pass this header? And if it doesn't find it, it's like, okay, well, I don't know you. You go away. Where are you coming from? And it will reject the request. But whenever we have this header, actually as part of the request, notification service will know who you are and will actually let you move on and send a notification. So let's do something crazy and just add this like change to this. You can see that as well, something, I don't know if you paid attention, but if this request fails, actually we are logging something here, but let's not log, let's actually throw that exception. So if you throw it, it will show very well in our API clients, Postman, and it will show that the request is gonna fail. So let's just remember, we just made a slight change to the API key, which means now the API key is invalid, right? So we're expecting now this request to fail. So go to Postman again, and we try to make a reservation. The seat which was reserved before, now it's gonna say you are trying to make a bad request because the key you're giving me is actually not the key I'm expecting you to give me. And how is notification actually service checking this? This is happening through now this middleware here that I promised about. Validate API key middleware. What it's just doing, it's validating if the API key in the header is the same as the API key that was issued to the client. And now here we are just calling that method we have seen to validate the API key. So you understand, this is one way of protecting actually two services that don't know each other through and have them connect through a secure way. So by doing so, notification service will know, okay, any clients that want to connect to me will have to provide the secret key that I issued to them that will know that I will trust whatever request they're trying to give. Of course, this can be developed further, but we're just having a glimpse into it. So now, this is only notification service trying to authenticate its request. People who are hitting notification service. What about the event service? So in some ways, let's say the event service will hit the notification service to send email notification, and notification service want to confirm back because those two services, remember, they're not microservices. They are just two third-party services that don't know each other. So in some ways, notification service, event service will have to be sure that this notification service really sent that email. And to do so, notification service needs a way to communicate back to the event service and tell them, okay, event service, don't worry, I've sent your email, right? So to be able to do that, notification service has to have a way to communicate with event service. So in the other way, event service has to provide a way for notification service to connect. So event service now decides to create another API endpoint to expose to notification service. So in the event service now, we are going to expose another API endpoint. We do that. And that we're going to call confirm notification sent. So this endpoint will just be exposed to any third-party service that the event service uses. And so they may just communicate back and acknowledge, okay, whichever notification was to send, we had sent it already. So don't worry, perform any action. So event service is going to expose this API endpoint so that notification service hits it back to confirm that, okay, I've sent your notification, right? So event service doesn't know also notification, or the event service doesn't trust notification service. Because remember, there are two services that don't know each other, but they have to communicate in some way. So event service is going to expose this, but even though it's public, it also has to have a way to check who is communicating to me, because you just don't have to misuse me however you want, right? What event services now decides to do is going to also want to validate requests that are coming from notification service. But in this case, notification service is kind. It's like, okay, I don't want you to do anything, but in every request that I'm going to be sending to event service, I will be providing a key, right? To tell you that event service, it's me, trust me. And remember, notification service had issued before an API secret key, right? So we had seen that notification service had issued the secret key to event service. So event service knows this key here. It knows that, okay, this is my key, and no one else has this key. So if notification service contacts me with this key, I will be sure that this is notification because no one else knows this key. It's only me and notification service. So if notification service contacts me back with this key, I'm pretty sure that must be notification service connecting back. So notification service now decides in each request that I'm going to be passing to you to event service, I will be sending this key, and event service will know that, okay, this is notification service that should take me back. So this whole concept is actually known as webhook request, if you have heard of the term. So it's a hook that event service is providing, and a hook can be integrated, can be hooked with anyone can hook into that hook. So in this case, notification service is gonna hook with that with event service to confirm back. So whenever now, let's go back to notification service right here. Oh, okay, we are there. So under app service, when the email notification is sent, we see we have this sent email notification method right here. So when the notification is sent, we want to connect back to event service. So we have sent the notification. Of course, here we are just logging, but we're doing anything crazy. But you want them to confirm back to event service that, okay, don't worry, you have sent the notification now, proceed with what you want to do. So what event service is going to do is going to connect back to event service and send another request, another HTTP request. And as well, in the header, you can see notification service is going to provide a key. In this case, we don't call it actually API key. We can call it whatever we want, but I just call it NS to mean notification service key. And this is going to be a key that's going to be passed to notification, so from notification service to event service. But this time, notification service want to be a little bit more secure. They don't just want to provide that key back plain as it is. So it decides to hash that key so that when that key is received, only the event service will know what that key is. So notification service actually decides up here where are we getting the key? It's right here to hash that key, to hash the API key. Remember, it's the same API key, my API secret key. That's notification service now decides to hash. And we are hashing it through that algorithm you see right there. And it's actually a mechanism that hashes in one way or encrypts in one way. So it's not like a cipher. You know, when you actually encrypt with cipher, you can decrypt that. But hashing with this method, HMAC, we only hash one way, encrypt one way. We cannot decrypt. And the only way to know the value of that, the real value now that is passed, is the only the person who has that secret. And remember, the one person who knows this secret is the event service. So you understand that no one actually in this case can be able to guess what value notification service has sent back apart from the event service. The only way anyone can know is if they know the secret key. And the secret key is, we assume event service has kept it secure, so we didn't export it to anyone. So this is actually a more better way to communicate as well back to a service, to another service, and letting them know that you are actually the person they think you are. So you hash that key in a one-way hashing, which cannot be decrypted, and only the person who has the private key will be able to know the real value. So once notification service actually send the request with this value in the header, what the event service is gonna do, we can still go to app service, and under app service, you see under here, send email notification. No, it's under here, confirm notification sent. This is the method that's going to be hit by the notification service to confirm that they have sent the notification. Of course, it's as well another HTTP request. So you can see how an API endpoint is called right here, which is public. So what it's going to do, what event service is going to do, it's going to have another middleware. Remember, middleware is a middleman in between. It's going to intercept any request coming. So it's going to say, to any request that actually comes, I want to check if the value that's being passed is the correct one. So you can see right here what it's doing. It's as well encrypting again the API key and then check if those values are the same. So with the HMAC mechanism, you cannot have a crypto-decrypt method. No. It's only the person. So the person who sends the request, they have to hash on their end, and you who receive the request, they have to hash on your end. When you compare those, they have to be equal to be correct. So if they're not equal, then it means there are two different private keys or two different things that were requested. So on the end of the event service, it's going to hash as well the same API key, which is right here, and compare if the two are the same. If they're not the same, then it's gonna reject that. It's gonna know, okay, this is not the person I think it is. Let's test class as well. So we are just going to pass here another key, or just a slight change right there. Yep. So if we go back to Postman and let's try to make another request there, we're still having another batch request. So wait a minute. I think we didn't change. I wanted to see this. We didn't change the change we did before. I think it was right here. Yeah, who remembers? I don't know, but it's supposed to fail. Supposed to fail. Either I did a change. I don't remember where I did it. Yeah, it's gonna fail, and you're gonna return an unauthorized. I'm not gonna throw an unauthorized exception. So it's gonna deny that request and say, okay, you are not the person I think you are. The other thing is you can as well change the key or change the algorithm that was used. It's still gonna fail. So if you change one of the two, it's gonna fail. So you have to the encryption has to be the same on both ends. So if the notification service encrypted, if that algorithm there, you on your end you have as well to encrypt that algorithm. So if you use SHA-1 or whatever 256, you have to use the same. If you use SHA-12, you use the same as well. Yep. So this is another way, enhanced the way we can say of ensuring the communication is secure. It's between two unknown parties that try to communicate. All right, so let's assume everything is okay. I'm going to remove all changes that I've made. Just a minute. Um, so let's move a little bit further. Now we have finished the assume we are done developing our application, and our application is ready to be deployed to production. I mean, we have to put it to the end of users. And then what are we gonna do? Remember, the intent here is to see how we can integrate security in our development flow, in our development journey. The journey ends in production. So what we're gonna do, we're gonna say, okay, let's test now our code. Is our code secure? I finished building our code, building my application. Is my application secure? Did I miss anything? Of course, we are humans. And to do that, we're gonna try a new tool. I think some of us are already familiar with security tools and IDEs, but we're gonna use one actually that I think you know already, Sneak, right? And we're gonna tell Sneak, try to go through our code. Just tell me, is there anything that I needed? Right? So what I'm gonna do, I'm gonna call Sneak. That's right there. Okay, I'm using PHP Storm, and then I'm gonna tell Sneak, please, I beg you, just scan my code and tell me if there is anything I missed, right? So Snake is gonna go through our code and try to find is there something that you probably omitted or a bad practice. Uh, so we can see already that somewhere in our code, Snake is not happy, right? It's not happy with us. So right here, we can see it's telling us it has coded secrets, which is true. Because you remember, we are passing the secrets plain as is, but we shouldn't, right? And it's telling us, suggesting us, boy, try to fix this, use at least the environment file to save them. So that's one way we can actually ensure that our code quality is actually better by integrating such tools, in our flow, development flow, to scan our code and sometimes tell us, okay, that's critical. We can see as well right here, it's telling us something. Oh, okay. I'm having a promise here that it's my fate at some point. I didn't catch it. So you see, this is not actually a crazy thing, but just reminding me that maybe you should just catch it in case it fails, right? Which is a good thing. So this is one way we can as well integrate security in our development flow to check on our code whether the quality is actually good before shipping our code to production. All right, so not everybody actually has a crazy laptop to run all these in their machine. Some people might prefer, I don't want to do this. Maybe my RAM is just it's not good capacity. I don't have a good CPU. And running this actually will slow my development. But don't worry, people have thought about it. So they created cloud tools. And so Snake thought, all right, let's give you a way to do that, but in the cloud. And now we're gonna try to integrate Snake with our repository online. So whenever we push our code, Snake is just gonna scan them online for you. So you don't have to use actually your computer resources. Oh, so what you're gonna do, you're gonna go to Snake Cloud, which is right here. And yeah, you just see the URL. You can just log in and you're gonna have that also there. And right here we have actually projects where you can add your projects. And once you add your projects, you can actually do the same scan we just did locally, we can do them online. And once Snips actually is done, it's now gonna give you the same reports. So you can see it's telling us after analyzing our codes right here, we have two critical actually conditions, two critical things that we have to fix. And one of them is the hard-coded API key. So it's smart enough to know that should be private, shouldn't be. And if we go a little bit further, it's going to even give us some suggestions. I think right here. So let's see the full detail. And yeah, just giving me where I made that thing and fixed analysis. Actually recommend us a way to fix that and telling us, well, maybe you can have a secret environment variable, you put your secret keys, and you can just proceed further and you will see all the suggestions that Snake provides to you. So you see, by doing this, you are actually putting Snake with GitHub, and it's just going to be scanning the project to test if there is any vulnerability. Of course, it's not only that, you can also go through your dependency tree and go and scan the dependency to build out the tag, any vulnerability found, and all of that report given to you. So this is actually it's just a quick and slight walkthrough on how it feels like to have security practices in our development flow. Thank you so much. Any question or anything you want to add on? Most welcome.